Welcome back. We did a little bit of work last time on taking fairly simplified reactions and putting electrons in them to balance them out. Often when you get a chemical reaction, it's something that looks more like this, where there's a couple different things going on at once. In here we have one story that's about aluminum, where aluminum atoms start out as neutral metal and then turn into aluminum ions. And at the same time, we have hydrogen ions turning into hydrogen gas. And these are easier to analyze if we actually split them into two separate stories. So I'm going to take the aluminum part of this, 2Al arrow 2Al3 plus. Okay, that's the aluminum story. And then separate from that, we're going to have the hydrogen story, 6H plus arrow 3H2. We can take each of those separately and work on it. Now, each of these, as you would have seen in the previous exercise, isn't balanced right now because in the aluminum one we have 0 charge on the left and we have plus 6 on the right. So if we were to balance this, we would need to put 6 electrons on its right side. And for the hydrogen, we start with plus 6 charge on the left. We go down to 0, so to balance this one, we would need to have 6 electrons on the on the left side. So these are what we call the two half reactions that come from this reaction. We have one where aluminum is losing electrons, meaning it's getting oxidized or reduced. If you think about Leo, losing electrons means you were oxidized. And the other reaction is a reduction. Hydrogen ions are getting reduced here and turning into hydrogen gas. So something you can check when you're doing this, at the end you should always have one reaction that is an oxidation and one that's a reduction. There should always be one of each. In other words, one of them should have its electrons on the right, the other should have electrons on the left. Let's keep going with this. This one has one story about chlorine, where Cl2 turns into 2Cl minus, and then it has another one where 2 bromide ions, turn into bromine. And if we balance these, chlorine's got 0 charge here. Here we have a total of minus 2 charge. So this balances if we add minus 2 charge to the left. And in the bromine, we have negative 2 charge on the left, but 0 on the right. So her right side is the higher one. It needs 2 electrons. Those are our two half reactions. Zinc and iron. We have a story where zinc metal turns into zinc ions. And then we have another story where iron 3 ions, turn into iron metal. What's our charge here? 0 on the left, plus 2 per zinc on the right, but there are 3 of them, so a total of plus 6 charge on the right. This reaction needs 6 electrons if it's going to be balanced. And in the iron reaction, we have plus 6 charge on the left, 0 on the right. Left side needs 6 electrons to balance out. Something you might have noticed, these numbers of electrons, if everything's balanced right, should always be the same because it's the same electrons. What the story that's happening here is zinc turns into ions and releases 6 electrons, which get sucked up by the iron, and it uses them to turn into iron metal. So these and these are talking about the same electrons. Just like if you buy something at the store for $6, there's a story where you hand over $6, and there's a story where the merchant gains $6. Those numbers have to match because it's the same $6 you're talking about. It's just changing hands. For you, it's a loss. For the merchant, it's a gain. So if those numbers don't match, it means your reactions aren't balanced properly. Let's keep going with this. Here we have a barium story where barium metal turns into a barium ion. And then there's another thing where two hydrogen ions turn into hydrogen gas. What do we need for electrons here? 0 charge plus 2 charge. The higher side needs electrons. Now that's balanced. And for the hydrogen, we have plus 2 charge on the left, 0 on the right. All better. Okay. You haven't asked any questions, so I take it you're kind of getting this. I'm going to go through the others a little bit faster. Here we have a manganese reaction, 2Mn7 plus, 2Mn2 plus, and then 10Cl minus, 5Cl2. Okay, total of 14 charge on the left, 4 charge on the right. 14 to 4, this side is higher by a total of 10 charge, so we need 10 electrons there. In the chlorine reaction, we have minus 10 on the left, 0 on the right. This is our higher side. 10 electrons there. Next one, 2 aluminum, 2 aluminum, 3. Let's mix it up and do these one at a time. 0 charge plus 6 charge. Need 6 electrons there. And for the zinc, what are our charges? Plus 6 on the left, 0 on the right. Now this left is the high side. It needs 6 electrons to even it out. Made up elements, 2Z4 minus turns into 2Z minus. What do we have here? Minus 8 charge on the left, only minus 2 on the right. Minus 2 is higher. And the difference between minus 2 and minus 8 is 6 steps, so we need 6 electrons there. And Q2 plus turning into Q3. Total of plus 6 charge from these ions. 0 charge here, there's no charge mentioned, so our higher side is plus 6. We can fix it by adding 6 electrons. And last one, nickel 2 turns into nickel metal. Plus 2, 0. We need 2 electrons on the left side to balance this. And calcium metal turns into calcium ions. 0 charge up to plus 2 charge. This side's higher, so we put in 2 electrons to balance it out. Quick review, this last one. Which side is an oxidation and which side is a reduction? Nickel's charge went from plus 2 down to 0. That's what I look for, and that tells me that this is a reduction reaction. The other way you can think of it is nickel picked up 2 electrons, and now it owns those electrons. So gaining electrons makes this a reduction. Or we could say nickel ions were reduced into nickel metal. On the calcium side, here's calcium, and now here it is again, and here's its electrons lying on the ground. Calcium lost electrons here, and if we look at Leo, losing electrons means this is an oxidation. So calcium metal was oxidized to calcium ions. Nickel ions were reduced to nickel metal. Easy enough?